Hi there. We're going to get some help today with lesson 89 from my friend the bacteriophage. Are you ready? You probably need some help from a bacteriophage. I guess because whatever. Lesson 89, identifying characteristics of quadratic functions. I got some words to define, but let me ask this question first. Do you like roller coasters? Some of you are definitely like, oh yeah, give me a roller coaster. And some of you are like, definitely no, don't you dare drag me on one of those things. I remember the first upside down roller coaster that I went to, and I probably said some words I probably shouldn't have said on the way down to the loop-de-loop. But then after that, I was like, oh yeah, this is awesome. Special thing called a clothoid loop when you go through the loop-de-loop. But I'm just thinking about one that goes straight and then either goes up over a hill or comes down and goes back up. You know, both of those times where if you get up over a hill, your stomach goes like this. And if you go down into the valley, you feel like you're being pressed down into your chair before you come back up. We're going to be discussing those points. The my stomach is going to come out my nose moment, and also the everything's being pushed down so hard, like if I was a Top Gun fighter or something like that. But unfortunately, there's no pictures up on the board yet, but we will get to that. If you recall, 2 lessons ago, we were looking at factoring things out, factoring out polynomials. And there's a couple examples at the end where we were trying to factor out, well, in fact, it was these two equations right here. This one took a little bit of massaging. We had to break it up into 4 parts and then kind of put it back together in a new way. And we factored it out into 2x plus 5 and x plus 3. And we had this other one here, which was probably a little bit easier. And we took 44 and we looked at the factors of negative 44 and broke that down to try to sum to negative 7. And we found them. We found negative 4 and 11. Okay? Now those we called them quadratic. We call them quadratic. Now, at least that was the form. If we put an equals 0, that would be like a quadratic formula. Equation. There we go. There's the word. Today we're going to talk about what would that look like if we drew a picture of it. That is, if we turn this into a function. Now you remember a function is a math machine. I put a number in, it does something to it, and it spits out a new number. Or really actually takes all the numbers, in the case of quadratics, puts all the numbers into the machine and out comes a picture. That's what's going to happen. A whole set of XY points that go along with things. Before we put our numbers, all the numbers into our machine and see what picture comes out, I want to do one more of these quadratic factoring problems here. And this is a simpler one, so this won't be so hard. But the little game was, we need to find the factors that multiply to make 7 that would add up together to make 8. Okay, now 7's a prime number, so really there's only one set of factors you've got at your disposal, and that's 7 times 1. And luckily for us, 7 plus 1 equals 8. That is to say, if we were going to factor this down into 2 parts that would multiply back together into the polynomial or to the quadratic, plus 7 and plus 1 would do the trick. Foiling, x squared plus 1x plus 7x plus 7. I'm going to be borrowing that today. I'm going to put it up in this form right here. I'm going to have a function where my input is going to be x into the equation x squared plus 8x plus 7. And then we're going to see what happens when I put values for x in there, what comes out. I already told you what shape it's going to be. But I could also put right next to that we could have written this in the form x plus 7 and x plus 1. I think you'll see in a few minutes why that is the case. Well, at least that's what we're hoping. Take your calculator out and go ahead and graph this thing in your y equals. We can replace f of x with y equals. That's what the function mode is for plugging in all of the x's possible and seeing what all the y's look like and putting that on a graph. Okay? I'm going to go and switch over to the very same thing so that we can kind of look at the same thing together. Hi. Now, hang with me here. Get out that calculator and put in the equation, right? And we could just graph this thing and see what it looks like. There it is. It's that parabola shape. It goes, if we watch it, let me type something in here so that we can watch it graph. If we watch it, it will graph the thing from left to right. It'll draw it in and it goes down, it reaches a bottom point, and then it came back up. Okay? That's pretty normal with these types of things. But a way to kind of investigate this a little bit more would be to make a table. And I've made a table that on my table start, I'm going to start at entering a -8 in for x and then spits out an answer for y. Or runs it through the function. I'm going to go by ones. And so I generate a set of ordered pairs like this. And what I'm going to do is I'm going to take these ordered pairs. I'm going to graph them one at a time. Okay, all we're doing here with this is we're taking the number that's in the x column and we're plugging it in to this problem right here. That is, if I plug in -8, what my calculator does is it takes -8 and it squares it, and then it adds that to 8 times -8, and then it adds 7 onto it. And the calculator tells me that the final answer for that is 7. Okay? And then it's going to go and it's going to plug in -7, and this thing tells me that when I'm all done, the answer is 0, and on and on and on. So it generates all these ordered pairs. I'm going to go out here to 1, 2, 3, 4, 5, 6, 7, -8. I'm going to put in that point 7. The next one is -7, 0. Oh, that's right there. The next point is -6, -5. 1, 2, 3, 4, 5. Then -4, -9. It's right there. And then what we notice is when we hit -3 in my chart, it says now we're going to start going back up. We're going to go start back, going back up. -3 corresponds with a number -8, and then if I'm at -2, I've plugged that in, it spits out the number -5. 1, 2, 3, 4, 5. Oh, I'm way off on these ones, aren't I? -5. 1, 2, 3, 4, 5. Had that one right. And then I went to 6, 7, 8, 9, and then back to -8, and then -5 again, and then we hit 0 right here, and then 0 goes along with 7. Okay, what we get here is that shape, right? And if I wanted to now, I could just connect the dots. Imagine this coming here, connect the dots here, and I see that I've got the shape that my calculator gives me when I hit graph. Now I did it this way because I want you to see a few things. I want you to see here the symmetry. See the symmetry here? That if I drew a line right down the middle, this picture is the same on the left side as it is on the right side. It's like a mirror image along this line. Another thing to see is that the lowest point is right on that line of symmetry. It's that point right down there. In this case is when we plugged in -1, 2, 3, 4, right? That we got a lowest value on the chart of -9. And every other point has a buddy across that line of symmetry. There's even these 2 points right here that cross the x-axis. Right? This is the x-axis right here, and at these 2 places, the values were 0 for y when I plugged in a number for x. All these things are pretty interesting. The lowest point down here, where it bottoms out, where you feel like super duper heavy on the roller coaster, that point there is called the vertex. The vertex is either a lowest point or a highest point. It's going to be a highest point if your parabola goes up and then it comes back down. It's going to be a lowest point if the parabola comes down and then it turns and goes back up. In this case, this vertex right here is a minimum. It is the smallest value that you're going to find in one of these types of problems. That's really important. On the board, we had either a minimum or a maximum. So we're looking for a lowest value, elevation-wise, in the parabola. We can plug in any x that we want to, but we're going to get on this case, we're going to get a certain value for y that is the lowest value we could possibly get. And that is going to occur at the vertex on one that opens up. Okay? Another thing we want to note here was the symmetry. It's the same on both sides. And then we have these important points here and here. These are important because this is where the function equals 0. That is, I plug in some number x, and the answer comes out to be 0. So maybe I guess in this case I plugged in a -7. That is f of -7, and the answer came out 0. And I also plugged in f of -1, and the answer came out to be 0. So these points here that we might think of being as x-intercepts in G, I guess in this world, we're going to call them zeros. Because they're what make the function equal 0, right? This one right here. And f of -1 makes the thing equal 0 as well. The last thing is this dotted line right here. This dotted line is called the axis of symmetry. The axis of symmetry is very important. It allows you, if you only had written half of this picture, you can write the other half of this picture very easily by, if you had a point over here on this side, you're going to find a buddy exactly symmetrical with it on that side. Here's one, there's one, here's one, there's one, here's one, there's one. Picture-wise, these are very important points on the picture of a quadratic equation, or we called it a parabola. I'm going to go back to the board and maybe talk about one or two more things before we wrap up this half of the lesson. Whoa, camera's getting a little wonky here. Sorry about that. If you got motion sickness, oh, that's so sad. Oh my word, this is bad news. Clock's running. How's that? Oh, just barely. Okay, shoot, I just wasted like 20 seconds. Here it is again. Remember the original equation was x squared plus 8x plus 7. You don't really see a -7 and a -1 in there, do you? Unless you factored this and thought about what would make this equal 0, right? We want to plug in some number that makes the problem equal 0. And those numbers would have been either a -7 or a -1. So that's where the zeros come from. They're actually hidden inside of that equation, but we can pull them out if we factor that. -7 plus 7 equals 0. 0 times whatever will make it equal 0. Two things I want you to see, though. Since this is symmetrical, it means that that axis of symmetry is going to be halfway between these two numbers. And halfway between these two numbers would be to add them together and divide by 2. Adding together -7 and -1 and dividing by 2 gets us at -4. There's our axis of symmetry. In fact, that is the x value of the lowest point. And how do you find the y value of the lowest point? You would plug that in to your equation, x squared plus 8x plus 7. If you plug that in for x into your equation, you get -9. So the picture and the equation, all that stuff goes together. Now I'll show you more about this axis of symmetry thing in the next episode, but that's all that we've got time for right now.